In this video, we're going to be going over the compass rear view mirror. Some of you longtime subscribers might be thinking, hey, didn't you already go over this repair? Yes, I did. In my previous video, I go over the most common problems with these that make the display no longer light up, and that is just fractured joints at some of these resistors. I usually reflow this one, these three. I always check these outside leads. These larger resistors usually reflow. But in this particular mirror, it has a problem that comes up from time to time. It's not a super common problem, but it's worth sharing. Located right here on the board is a 7805 voltage regulator. I'm currently providing the mirror board the 12 volts it needs. And if we take a look at its inputs and outputs on that voltage regulator, so this is the input. As you can see, we got the 12 coming in, and on the output pin, 3.6. That is not correct because this is a 5-volt voltage regulator. So what happens if we actually put 5 volts on the output of that voltage regulator? Currently have my other secondary power supply set to 5 volts right here, common ground. And if I give it 5 volts, look at that, it comes to life. If I can hold it steady. So there we go. I can see the vacuum fluorescent display is lit and it is working. And also, while we're doing that, I'm going to put you on the power supply so we can kind of keep an eye on the power draw that's going on through that 5-volt circuit. So here is the 5-volt power supply. We're going to monitor the current that's being pulled through that 5-volt circuit. I'm going to go ahead and connect it up right there. Okay, the mirror is now on and we're drawing about 120 milliamps, which is a good sign. That tells me there isn't a short somewhere that is causing that voltage regulator to be pulled down. It's 120 milliamps is very low power. And here, just to confirm one more time, I'm testing the output of the voltage regulator. We're at 3.6 volts, which is wrong. But when I go ahead and put 5 volts on it, you can see there everything comes to life. We're now at 5 volts, and it is working. So it does confirm we have a voltage regulator problem. And when we remove the 5 volts, we're back down to the 3.6 again. And yes, thanks for noticing. I am using a different multimeter today. This multimeter was just released. It's only about 2 weeks old on the market, and it is a 3-in-1. So it is a signal generator, oscilloscope, and a multimeter all in one. There will be a 25% off coupon code down below. Time to yank this bad voltage regulator. Turn up your hot air stations a little higher than normal because there's a lot of copper and a lot of metal here to unsolder. With the failed voltage regulator removed, I now get to decide what I'm going to do for replacement. I don't have an exact match in this package of 7805. Now I can use an LM1117 style voltage regulator, and being that there's only 120 milliamps being pulled through the circuit, that shouldn't be any problem at all because these are good for 800 milliamps. They're physically smaller, which is okay. Again, they're good for 800 milliamps, so it doesn't matter. But the pinout configuration is different, so I wouldn't be able to directly mount this. I would not be able to use the heatsink on the heatsink pad. So I think what I'm going to do is, I do have a 7805 and a traditional TO220 package. It's quite a bit physically bigger, as you can see. But if you look at the way they designed the board, this ground, or the heatsink pad, which is the ground, does continue all the way up to just about the edge of where this resistor is. So this entire piece of foil here is all connected together. It's all the same ground plane, which does leave just enough room for a full-size heatsink for a full-size TO220. And I think I can make that work. So I think that's what I'm going to do. As long as I don't let this ground heatsink come in contact with this resistor, it should work good. Not only good, but it'll give it a lot more heat sinking than what this originally had. I think I'm going to do that. Let's try that. The new voltage regulator, I did have to mount it just a little bit crooked so that way I wouldn't have to worry about the ground of the heatsink touching the contacts of this resistor. So, should we try it? See if it works? Ooh, look at that. It is working. Nice. Before putting it all the way back together, I do like to clean off the inside of the little display window here. Over the years, there's always a little bit of, I don't know, sediment and dirt and dust or whatever. There's always like a little layer of slime on the inside of the glass. After years of being in the elements of a vehicle. So I just like to clean these little display windows so it looks good when it's all the way back together. The rest of the back side of the glass doesn't matter because you can't see it. So with this style, before I put the glass back in, do need to clip on these leads back. Come on, there we go. Okay, we'll clean the front side of the glass after it's assembled. All right, so we gotta get the buttons back on. Here's my buttons, button panel. Let's just make sure that the contacts here are clean and didn't have any flux that made its way back to the front side of the board here. Yeah, that's clean. So let's feed these through. There's little rubber nubs line up with holes. And just if you give these a little pull, they'll kind of lock into place. All right, there we go. Before we go too far, this guy has got to go in here. That's what shows through on the back side of that window. Okay, buttons are locked into place. Go ahead and set that in. Everything feels like it where it needs to be. That's good. That's good. It's centered, and then we just have to do the plug clip here. No, you're not able to see what I'm doing, but I'm just getting this plug lined up and back in here. Okay. Plugged in, making sure everything stays where it needs to be. There we are. Let's give it one more test. Turn on my power supply. There we go, we have a display. And then I like to hit a flashlight in the back of the sensor here to make sure it kicks into high brightness. And then this will light up in here and the display will get a little bit brighter. Got the flashlight on the sensor in the back. It takes about 30 seconds or so for it to kick in. There it is. See the vacuum fluorescent display got a little brighter, and now this is lit up orange here. So that is it for today. If you do not feel comfortable doing this kind of repair yourself, I will have my email down below. And you can contact me for repair service. Otherwise, I have a few of these for sale too if you just want to purchase one. Again, my email will be down below, and so will the link and the coupon code for the multimeter I used today. Thanks for watching. We'll see you in the next video.